in our quadratics unit, Unit 3. It's called regression because we start from a set of points and work backwards to find your equation. So for our first example, we're going to use these 3 points. You have to have at least 3 points to model a curve, and find an appropriate quadratic equation that models that. And to do that, we're going to use Desmos. So if you look at, you can just search for desmos.com. And when you do, you go to, we're going to add a table. These points, instead of listing them as points, I'll type them in as a table. So here are my x values, and here are the corresponding y values. Okay, and these are plotted as I type them in. And then I need to add a regression equation. So I'll type in y1. And first I'm going to make a standard form equation, which is ax squared plus bx plus c, like this. I have to put this little symbol in so that the computer knows that I'm not just typing in an equation, that it's supposed to look for an equation and use these points. So the computer knows to do regression. I finished typing ax1. You have to type in x1, y1 so that the computer will refer to the table instead of just regular x and y. Okay, and there's not anything in particular that you need to do to make the subscript appear. If you just type regularly on your keyboard y1, x1, then they are placed down low like this as a subscript. So once I put my table in to Desmos like this, and I type that in, my graph appears, and I get my A, B, and C values, and I can substitute that into the standard form equation and get this: y equals 1x squared plus 4x minus 1. This is what you're asked to do on several of the problems that you have on your practice. You're given either a table of points or a list of points or a graph for which you could pull off points from just whatever's on the grid mark. And then you can type those in as a table in Desmos and type in your regression equation and find A, B, and C, so that then you can substitute and write the standard form equation. Some of the problems that you do on your practice ask instead for the vertex. So in Desmos, I lost my mouse. Here it is. I can click on the vertex. That's here where it changes direction from decreasing to increasing, the middle. My vertex is -2, -5. There's a vertex form of an equation, and that's this. We do more practice with this in lesson 3, but just so you know, this is a vertex form equation, and I can type this in Desmos as well. So let's do that. y1, I need that squiggle, which is on my on-screen keyboard. If I type ABC or hit the button for ABC, then it's right here. Now I'm going to do A parentheses x1 minus h squared plus k. And I don't know if you noticed, but here I just got a blue graph exactly where my red graph was. So these are different formats. This is standard form. This is vertex form. They represent the same curve though. There's a different way to write the equation. And that's useful to have a vertex form equation because that way you can read from the equation what the vertex is. The vertex is hk. Here, h is -2, k is -5. -2, -5 is my vertex. That's why we call that vertex form. So if I write down a, h, and k and substitute them into my vertex form equation, I get this equation. 1 times x minus -2 squared minus 5. And that's a really awkward way to write that equation. Normally we would write y equals x plus 2 squared minus 5. And like I said, those two represent the same